Today on the Data Show, we're going to talk about probability and then discuss a study that attempts to associate pollution with dementia. Today on the Data Show. Greco, the Data Show host. For the next 30 minutes, we're going to be talking about things like how to collect data, how to analyze data, how to figure out different aspects about whether data has a veracity to it, a verifiability to it, redundancy, all those things that are very, very important when it comes down to data. So what I want to do first of all is I want to go over a refresher. Now, I tried this in the last episode, and I'm afraid that I just kind of messed that up. So I'm going to try again to do this so that people understand the difference between or and. And I think that's very, very important. So we're going to do that first of all, and then we'll go into this pollution and dementia and the attempt at associating pollution with dementia. And I think this is, just to get off on this track just for a second here. It seems to me that what's happening is a very logical, it's called a hypothetical syllogism. And if you've never heard what a hypothetical syllogism is, let me just go over this with you real quick. So a hypothetical syllogism goes something like this. If A equals B and B equals C, then A equals C. So that's what a hypothetical syllogism is. A equals B and B equals C, then A equals C. So if climate change causes pollution and pollution causes dementia, then climate change causes dementia. And I think that's what's happening. Everything is coming down to climate change. Everything. I mean, I don't care whether you got it gets to the point of hyperbole and panic. And that is exactly what media loves to do. Media loves to take data and they love to shove it at you, and then they love to make it into a panic, because then they can report on the panic. Then they can report on that. I've told you this before and before and before. It is the self-licking ice cream cone. You have something happen, and then boom, you report that happening. It just so happens that you made it happen, but that's okay, because there's no longer reporting the news, it's making the news. And that's what the media is out there doing. Media is out there making the news instead of reporting it. And they sit back and they go, no, we didn't make this news. Of course you did, because what you did was you associated things with other things that shouldn't be associated with them. And I'm saying causation, and not so much, because what you have here is you have correlation and causation. And I've gone through this before. If you have causation, then you automatically have correlation. But, and this is a big but if you have correlation, you do not automatically have causation. And this is the hardest thing to get across when it comes down to probability, statistics, and the rest of that. And that's what I'm going to show you today, is just a little bit about this probability stuff and how and or kind of come together. So let's go over some refresher. First of all, you have the addition property, which is an or, multiplication property, which is an and. If you have two things like Joe is going to clean his room and he's going to wash the car, So you have the probability of cleaning the room, and then you multiply the probability of washing the car. So basically, what I did was I kind of extrapolated that. I went into Jackson, cards, right? Jackson clubs. So how many jacks do we have? Well, you have basically 4 out of 52 jacks. 4, right? You have hearts, diamonds, clubs, and spades. So you have 4 jacks, and that's it. Now, how many clubs do you have? We have 14 out of 52 clubs. No, you have 13 out of 52. Sorry, 13 out of 52 clubs, right? A quarter of the deck, basically, is what you have. It's right there. Now, to get an and, what you're going to do is you're going to take a jack of clubs. So what is the probability that there's a jack of clubs in that? Well, you have jacks and you have clubs, right? So now you have 0.019. That's what you have. Or if you really want to get percentage aspects, you got about 2%. Got a 2% chance of picking out a jack of clubs from a deck. 2% chance. It's not that bad, really, when you think about the percentages and everything else. Now, if you have an or, that means you're going to have a jack or a club. A jack or a club. So basically what happens is you have the jacks plus the clubs, right? Minus the jack of clubs. Because the jack of clubs, you do not want to count double. You don't want to count that double. So you have to subtract that. So you have A12 plus B12 minus C12, the and that's how you come up with about 31%. You get about 31% chance of getting a jack or a club. A jack or a club. You add if it's or, you multiply if it's and. And this is where a lot of people get confused, especially in probability aspects, because everyone sits back and they go, that doesn't sound right because and means addition. That's not true in probability. And that's very, very important to understand that when it comes to probability. So now let's take a real case. I mean, this was a real case, but it had to do with cards. But let's take a look at the probability of a Black American with a American who's American who has a history, whatever you want to call it, of their grandparents or great-grandparents, great-great-great-grandparents, whatever, were African. And Black may not mean, it may also mean Caribbean, right? So there's all these different aspects. So basically Black Americans. So you have Black American right now. So here's the number of Blacks, non-Hispanic, in the United States is 0.136 or 13.6%. Where did I come up with that? Well, I came up with it right here. So I came up with it right here under Quick Facts. Census.gov Quick Facts. And here it is right here. And it has Black or African American alone percent 13.6. 13.6. And this is 2022, but it's, basically that's what they have, 13.6%. So that's where I got it. So I mean, I'm not making this stuff up. So that's what I have here, 13.6%. Now, what about diabetes? What's the possibility of an American, any American, having diabetes? Current CDC, here it is right here, there it is right there, is 8.7%. 8.7%. Now, what am I going to do? What am I going to do is remember, I have to add. So I'm going to add, my and is going to be A2 times B2. And that's going to come up with 0.012, or about 1.2% have Blacks will have diabetes. So it's again, it's a probability aspect, right? So it's not a for sure thing. It's not like you can do this, and this is why it's very, very important to understand. Very, very important to understand. This is not a surety. This is strictly probability and the ability for us to take these numbers and put them together. So 0.136 times 0.87, 0.012. And that's what it comes up to be. So that's what we have. Now, how does this work? And I tried to do this before. So let's say that I have two shapes, right? I what they call a Venn diagram. So what I'm going to do is I'm going to take one here, okay, and then I'm going to take another one here. So this is what I have. Now, if I take this, right, and I try to get the outline, I'm going to do weight, shape fill. So I'm going to try to do transparency here and see if I can take this and put this into the ability of a Venn diagram. And in the Venn diagram, you're going to see, so I'm going to take this one, and this is going to be A. So this is going to be, it's going to be a number of blacks, and this is going to be diabetes. Of course, it's going to be smaller, right? Because it's a real small thing. So I'm going to make this small, because this is 0.0. So it's about, there we go. All right. So this is blacks, and this is number of U.S. right here where these two things meet. And I think this is important. So let me see if I can actually get this to the point where it does this. But all I want to do is try to make it so that when you do the formatting shape, you're going to have a transparency. And this is pretty cool when you can do it. So now I'm just going to get this transparency aspect here. See if I can make it work. So line, there we go, line, there we go. So we're just going to take the line and we're just going to make this transparency thing go here. I'm going to try to send this to the front, the back. So if I take this one, do the same thing, and try to make it so that it's transparent. Let's see if I can make this go here. So I mean, if I can make this, I can make this go transparent. So if I can make this work, you would see it. You would actually see the two lines here cross. And I think this is important. So this area right here is where the and is, right in this area right here. So if you can do it that way, you can see that and that's going to be your 0.012. Your or is going to be where this and this basically go together, 0.223. In other words, black or diabetes. And that is where those two come together. So I think that's pretty important when it comes down to that. And it's something that whenever you take a look at this, you can sit back and say, okay, this is what I want. This is what I need. And then you can go from there. But it is interesting how when you take a Venn diagram and you try to show it in class, especially, people kind of like, I don't really want to do this, what the heck type thing. But there it is right there. In fact, you can just barely see it. See it? I mean, it kind of goes this way. Just barely discern it. But that's where that's going on. And I think that is, see, I mean, there it is right there. See if I can get, so I can make that color bigger. I can make so I could make this bigger here. You can actually kind of see how that goes, and that's the and right there. So that's important, and it goes to being able to make this work from the standpoint of and you have a race and diabetes, and that's pretty important when it comes down to that, because this is all Americans with diabetes. This is blacks and diabetes kicks into that. And both of those you can get from government. Get this one from CDC, which is diabetes. You get this one from this one. You get this from the census.gov. So in both situations, that's the way that goes. So that's what you want to have, and that's what's going on there. Now, so much for that. Let's go into Journal American Medical Association came up with a study, comparison of particulate air pollution from different emission sources and incident dementia in the U.S. So this is from the Journal of American. This is from the Journal of American Medical Association. It is unbelievably good from the standpoint of sources and what exactly is going on. It has the ability to take a look at it and see what's going on. Now, the question or hypothesis, right? The question, are long-term exposures to particulate air pollution from different emission sources associated? This is not, and this is correlated. I mean, they don't like to use correlated because people are starting to understand what correlation means. Correlation is not causation. I keep saying this, keep saying it. Nationally represented cohort, whatever it is. Emerging evidence indicates that exposure to fine particulate matter may increase dementia risk in older adults. Emerging evidence indicates the exposure risk. They give sign setting participants, may not comes in measures. Good 27,000, almost 28,000 participants. Good age, mean age, 61 with a standard deviation of 10 years. If you're going to go out 3 standard deviations, basically that goes 91. The other way is going to be 31. So I mean, the standard deviation is pretty wide. 56.5% female and 15% developed dementia during a mean follow-up of 10.2 years. Now, let's just take a look at this just for 1 second. Age 61, mean age 61. 10.2 years, that's 71. So you sit back and you go, wow, that's a lot of years. It is a lot of years. That's a lot of years to follow, which is really good. It's basically a longitudinal study almost. And then you talk about that. Now let's take a look at what they call the risks, right? The hazard ratio is what they call it. 1.08 per IQR, 95% confidence interval, 1.01 to 1.17. What does that mean? 1 means there's no difference between the treated and the control group. I mean, there's no hazard risk. There's no difference between people. There's no hazard risk. There's no hazard to it. So what are we talking about? 1.08, very small, folks. It's a very small rise between 1 and 1.08. So that is something that's interesting. Then they talk about the different aspects. 1.13 here, 1.05 here. So wildfires, 1.05, agriculture, 1.13, were robustly associated with greater rates of dementia. Robustly associated. What does robust mean? It means in statistical terms, I don't know whether they meant it this way or not, but robustly means that it's not affected. It's not affected by highs or lows, like a mean is, which they use, which is not a robust measure, but that's okay. So in this cohort study, higher resolution, blah, 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 it says these findings also indicate that intervening on key emission sources might have value, although more research is needed to confirm these findings. So what does this all mean? Well, they went through the sources, they went through the deals of what's going on there, and they tried to figure it out for what they call incident dementia. But bottom line is this: particulate matter 2.5. I think that's the size of the particulate matter. I can't remember if it's millimeters or they're small, relatively small particulate. But wildfires are going to give probably more particulate matter than agriculture is. I mean, but that's just a guess, and it's a guess on my part. So it's a guess aspects on this. So I mean, the bottom line on this is that, again, why are they doing this? Incident dementia in the U.S. Why are they doing this? They're doing it for a couple of reasons. One is that somebody, whomever did that, um, whoever whoever looked at this, even funded it and whatever else, wanted to take a look at what the deal was from the standpoint of pollution. Now, what's causing pollution? Well, I'm going to tell you that the bottom line on this whole thing is that pollution is caused by a wide variety of sources. It's caused by automobiles. It's caused by smokestacks. It's caused by people. And this is what the Journal of American Medical Association is trying to get to. And again, you have to go back to logic, right? If climate change is causing pollution, and they're saying, well, it is. It's causing sources of pollution. I mean, climate change causing wildfires. Look at the wildfire situation. Of course, but there's no proof. There's no scientific proof that climate change causes wildfires. There's an association between climate and wildfires. There's an association between that. The causation, I don't know. Maybe you could take that leap if you want to, that type of area, but there's been no studies that I've seen that actually show that climate change somehow is causing these wildfires. So that's an interesting aspect, because it's really hard to go back 100 years and say how many wildfires were there 100 years ago and what type of climate was there. So that's, and people try to do that, but that's a tough one. If you go back 100 years, 200 years, 300 years, that's an issue. And climate, according to the definition of climate, is 30 years. So every 30 years, we're going to have climate change, although some people say, well, it's not even 30 years, it's every season we have a climate change. Yeah, that's a weather change. But weather is more short term than climate is. Climate is a little bit more long term than that. You got to have weather to have climate, and but that is goes around and around and around with people, especially if they want their voices to be heard. But that is Journal of American Medical Association, which is highly reputable. And at the end, you can see that they qualify that stuff. And let me read it to you again. It says, these findings also indicate that intervening on key emission sources might have value, might have value, might have value. I think that's really, really important. When you read these studies, there's no certainty whatsoever in these studies, although more research is needed to confirm these findings. So, I mean, there it is. And that's how study authors get away with this stuff, is that they sit there and say, more study needs to be done, more research needs to be done, more things need to be done. So it goes round and round. So the data out there, when you take a look at this data, it is the data that pertains to that study. So then people go out there and do meta studies, which then means they grab a bunch of studies and they put them together and they do whatever they need to do. And yeah, it's good. That's good, as long as all the studies have data that is compatible and standard. If you do that, then you can do apples with apples and you can make it work that way. So it's a really difficult thing to do. I'm not envying. Trust me, I do not envy the study people that go about doing this stuff. It's really difficult. It's difficult, and especially when it comes down to trying to prove something. So that really does it. I wanted to make this a relatively quick episode, and I wanted to have those two things, the probability aspect, and then I wanted to talk about this one study. So I will quit you. I will quit you. I will stop this early, and you can go about your business and have fun with your family and do whatever you need to do. And I hope that I have not taken up too much of your time. And I hope also that when you understand this, when you understand more and more and more about these studies, that you can take a look at it from a very specific viewpoint and take a look and make sure that things are happening. So while that's going on, let me do one thing, and that is let me talk about my book, which is A Data Analyst Walks into a Bar Graph. It's on Lulu. It's also on Amazon. If you have any type of interest, please go about doing that. If you want to, you can email me at this email. And um, for any questions or anything else that you want to do, anything else that you want me to discuss, I'm all in from that standpoint. And what I want a little bit about what's going to happen on the next worldview is we're going to talk about the changing the changing terrain that is happening in Europe from the standpoint of assistance to Ukraine. And I think this is really, really important from that standpoint. And also, I'm going to touch on why 2-star and 3-star and 1-star and whatever generals you have talking to you specifically about the news and about, oh, we need to put more money towards Ukraine. Take a look at their names and start vetting them. Start actually looking from a data point of view. Look at where are they now? What are they doing now? Do they happen to be in charge of companies that produce weapons? Because if they are, isn't that a conflict of interest if they're saying provide more weapons to Ukraine? Does that not make their testimony suspect from the standpoint that they're going to be making money off of providing weapons to Ukraine, and they're on the media saying we need to provide more weapons to Ukraine? So all these things we need to do more and more vetting. We have to be more skeptical about just hearing what the media has to have, and these experts that are coming on and talking about these different things that are happening. It's nice to have experts, but you got to vet them. You have to make sure that what they're saying has some credibility. And I don't care if they're 2-star generals. I don't care if they're 3-star generals. I don't care. If they have a conflict of interest, then what they're saying should be qualified. It's not equivocation. They need, it's not an equivocation. They need to equivocate their statements. And that's going to be all on the worldview. We'll talk about that next time. So in the meantime, please, whenever you're talking about data, always understand and remember that you have to vet the data to make sure that it has veracity, has truthfulness. There's some aspect of doing that. And remember also that correlation is not causation. Until next time, this is Chris Greco from the Data Show saying, check the data.